Okay, here's the example again. We have 168 Newton sine supported in a motionless position by two ropes that each make 22.5 degree angles with the horizontal. What is the tension in the rope? So there's a picture of the problem. Here's my solution using the procedure. First, you do given, find, and solve. So here's a picture of the problem with what's given. We know the weight of the sine is 168 newtons. We've got these two ropes, F1 and F2, at these angles. And we want to know what are the tension in those ropes. So let's solve it. Well, step 2 is to draw the free body diagram. So here's my free body diagram. 168 newtons of weight pulling down. You got F1 and F2 like this at their angles. Step 3, let's make to the right X and then up is Y. So identify my X and Y axis. But look at F1 and F2. They are at angles to the X and Y axis. So here's F2. So here's F2 in the X and F2 in the Y. F1 in the X, F1 in the Y. So I show the component vectors on my free body diagram, but I do it as dashed lines. So I finished step 3, so we do step 4. I'm going to sum the forces in the x direction, equals MA in the x. So I look at my free body diagram. Here's F2 in the x. It's in positive, but look, F1 in the x is negative. Equals 0. Why the 0? Because the object is in equilibrium. This tells me that F1 in the x is equal to F2 in the x. I just put this on the other side and switch the order. But what is F1 in the x in terms of the angle here? Well, this is the horizontal component of this, and here's my angle. So it's the adjacent leg on my right triangle. So it's going to be the hypotenuse, which is F1, times the cosine of 22.5. And the same is true with F2 in the x, and it's the same angle. So it's F2 times the cosine of 22.5. The cosines cancel out, and so you have F1 equals F2. So I get that from summing the forces in the x direction. Now in the y direction, so let's sum the forces in the y direction equals MA in the y. Well, I look at my free body diagram. I got F1 in the y plus F2 in the y. See, they're both in the same direction. They're both in the positive y direction. Minus 168 newtons because it's going straight down. Equals 0. Why does it equal 0? There is no acceleration in the y direction. It's in equilibrium. Now it's just a lot of algebra and a little bit of trig. F1 in the y is F1 sine 225, right? It's the opposite leg of this right triangle. Plus F2 sine 22.5, right? Same thing. Equals 168. I put the 168 on the other side. But here's the deal. F1 equals F2. So this lets me do a substitution. Just say, hey, look at this F2. Let's just say that it's equal to F1. It is. And so now I've got F1 sine 22 plus F1 sine 22.5 degrees equals 168. Now I can combine these into, it's 2 F1 sine 22.5 equals 168. So to solve for F1, I take 168 newtons, divide it by 2 times sine of 22.5 degrees, plug that into your calculator, you get 220 newtons. So F1 is 220 newtons, and since F2 is equal to F1, they're both 220 newtons. They're in different directions, but the magnitudes are the same. Okay? And notice, let me zoom out so you can see the whole problem here. I'm just using the procedure that we learned in the last unit. I'm just expanding it a little bit to take forces that are in the x and y, that have x and y components, and including those components in my x equation for force and my y equation for force. It's a little bit more complicated.